Hello guys, welcome to another live stream. So first off, the reason why having this live stream by this time is because life happens, right? And you know have so many other responsibilities here and there, plus like 9 to 5. Trying to balance everything together with content creation is not easy. Most times. So please, I would say bear with me. So today we'll be doing three problems. I don't want to waste much time, because I've already usually I have to wait for like 10 to 20 minutes for people to start joining the live stream before I start streaming. The purpose for doing this is so that more people will get to join on the live stream, and we can now start talking and making this content. So I'm actually trying to okay, so I was actually trying to edit my background. Anyways, so let me not waste much time on that. Let's just start. So what I'll basically reduce the size. Yeah, so I think that size is okay. All right. So I think on Twitter we have about 80 people on the live stream. Guys, there's a chat section where you can drop your messages. If you have a question, any question from me, you can drop it there. And by the way, I just want to use this opportunity to say thank you to all of you that join on these live streams. On I was able to cross the mark of getting above 400 followers on YouTube, which means a lot to me because YouTube has been one of the most difficult platforms for me to grow on. But then keep making this content, we keep putting them out, and we keep trying our best to create value as much as we can. So the first problem I will be solving today is basically called encode and decode. So we are encoding and decoding a string. So basically the question says, let me split it into. So the question says design two functions. So it says encode, which takes a list of strings and combines them into a single string. Then another one is called decode, that takes that single string and returns the original list of string. So strings can contain any character. So from what you can see here, you can see that we have like, an example. So we have an array of, strings. So we have hello and world. If we encode it to a string, and when we decode it, it gives us, hello world back. Same thing for, this, and same thing for this. So this is quite tricky, and at the same time, I would say it also has like an easy side to it. So first of all, as we usually do, I'll go ahead and comment out this question. Then I would start from our encode, right? So first, I'll also comment this out, and I would comment this out. So the purpose for this is so that as we go through, coming up with solutions for this particular problem, we would be able to test it, run the code, see what's inside the code as we keep going down. By the way, guys, we have like 80 people on the live stream, but we don't have enough people retweeting the live stream. Please help me retweet the live stream, like it, share it with someone. It means a lot. Thank you so much. All right. So we'll start with the encoding. So the first thing that we have to do is, how do we encode our string? And the way we encode the string would determine how we'll be able to decode that very string, right? So we have to think very careful about it, right? So now, how do we do that? First off, if you think about it, we would need the length of each string in our array to be able to, you know, encode our string. And as such, we would also need a separator between, the length and the word itself, right? When we are doing our encoding. So, for instance, we want, if like in the case where we have like, this, so let me copy it. So in the case where we have something like this, we want to encode it with, first we'll say, hello has, 5 characters. So we want something like, say the length of hello is 5. Then we want to separate it with something, maybe an underscore or hash, right? Then we'll then add hello, right? We do that. Then for the next one, we want to also do the same thing for world, right? So we want to count how many, like get the length of world, right? And we then say hash, WORLD. So this would be the format of encoding, right? And it would be like a colon, but in this case, we're going to you know, a hash, right? So we'll encode it this way. Then our decoder will be able to take this and give us back what we initially encoded. So we're basically encoding and decoding. If you've used like crypto libraries in JavaScript, I think the JavaScript crypto library has like, it gives you the ability to write functions that can off and the code you've worked in like fintech or like let's say a bank and or where they mostly encrypt every payload, request and response that they get for security reasons. This is something that you definitely deal with. I've dealt with it like a lot of times, right? I'm working on this kind of applications that has to be secured. So, it's basically the same thing that we are doing here, but we're doing it in a very, very simple and naive way, right? In the most simple way possible. So, guys, once again, thank you so much. We are about 114 people on the live stream. Please help me, share, retweet this tweet, like it, so more people get to, see it and come online. Like I said, the reason why we're having this live stream late today is because, life is life, right? So, um, this is the best time I could, afford to come online and, do this do this live stream. So once again, thank you guys so much for supporting, always being here, when I make these live streams and all. It means a lot to really go live and see about 117 people on the stream. I really, really appreciate each and every one of you. All right, so without digressing so much, how do we take an array of strings and turn it into this? So it's simple, right? So the first thing we have to think of is we need a way to, hold our strings, right? We need a way to hold our strings. So the way we do that in Rust, we say let's mute, we'll call it, let's call it value of string, val str, and we say string dot new. So this is how we, do it in Rust. So now, what do we do? Since we have an array of string, we can loop through this array, get the length, because remember we are following this format. We can get the length. Then when we get the length, push it into this string, right? So for those that are not familiar with Rust, or for those that are still learning Rust and everything, what string.new does for us is that it creates, a string on the heap, right? It creates a space in memory on the heap for us to, insert things, or for us to declare a string or add a string to it. So that's basically what this is, right? So, like I said, we will loop through this array, and for every iteration, we'll get the length, push it into the string. We'll get, our divider, which is the hash keyword here, push it into the string. Then we push the actual string itself, right? We'll do that until, we're at the end of, the array, and we can no longer iterate again because we got into the end. So in order to do this, we'll say for str in strs in strings. So this is coming from here. So we cannot use str because it is a reserved Rust keyword. So let's just use S, right? So now we have that, right? So now let's just log or print. Sorry, coming from a JavaScript background, TypeScript, I'm always used to saying, log. So um, print. So we're just printing. Let's print S and see if see what we have in S. So print S. Okay, we have errors. Okay, of course. So we have to comment out that line. Run it again. Of course, you can see we have hello and we have world, right? So now we know that we have those two words. So we'll go ahead and we'll create our encoded string, right? So the first thing we'll do is we want to get the length, right? So we say value of string. So this is this. So there's a keyword in Rust that we use. So it's called push string. So it enables us to push a string into this space that we've created on the heap in memory, right? So we say val underscore str dot push string. So for that, we would pass, say the s dot length. So we want to pass s dot length, and of course, we want to make it a string, right? Because I think it has, it will have the type of an I32 or so. So we want everything to be a string. So we'll say dot to underscore string. So we'll do that. Then the next one we'll do would let me just copy the push string because we don't have much time, right? So we'll now push in our divider. So our divider here is the hash keyword. And then finally we'll now push in the string itself. So pushing S. So I think we should use a reference here. All right. So we have this. Okay. So we'll take our print and we'll come out here and we want to print, value underscore print underscore string to see what that value is. So we want to see what we are pushing into this string, right? So we'll run this. Of course, so you can now see that we have this, we have this encoded string, right? We've created. So the reason why, once again, the reason why we created it like this is because we want to be able to like have the length, then we have our divider, then we have the actual string, right? So we'll be doing some sort of like manipulations, and so I'll write like code to decode it, which is I'll try my very possible best to explain as much as I can, so that you can take that same concept, go to other languages, and apply it. At the end of the day, it's still the same thing, right? So I'll try my possible best to do that as we go on on this live stream. So once again, guys, please help me retweet the live stream. We're about 136 people on the stream. Thank you, guys, each and every one of you for joining. All right. So now we are done with So we'll just sanitize our code. So we are done. So what we'll do, we'll go ahead and we'll just return, instead of returning an empty string, so we'll just return value of string, and we'll remove the print. So automatically, right, we'll then uncomment this guy and uncomment this guy. All right. So now we've uncommented those guys. Let's go ahead and in our decode function, right? What's the first thing that we'll do? In our decode function, let's print. So we are printing S. I think let me just use. We're printing S. So let's see what printing S is going to give us. Of course, you can see, right? So we have it here. So the first one we are seeing here encoded is printed here, right? Then we are printing, the second one here, right? And then the final, vec itself. Right? So that's basically what we are doing. So you can see that this is exactly what we don't even need it. We don't even need to print it here, but just for the for the sake of having it directly in that place, so we can confirm that yes. And in case you don't believe me, I'll add SSS here, and I'll print again, and you see exactly. So this is it, right? So this is exactly it. So now, as I was saying, okay. So as I was saying, we'll then we now have to think of how are we going to take this string that we've encoded and decode it back to what we used to have, right? How are we going to do that? So we have to think very carefully of you know what we do at this point, right? We need to think very carefully about it, right? We have a string. How do we you know move through this string, get the length, you know, separate the divider, push that particular word into our array, mark it, do the same thing for the next word, and we'll continue doing that until we get to the last place. So the first thing we want to do is, for our example, something like we have here, we want something like this. So let's say um, we want something like this. We want like an array of different characters, right? So let's say we want something like this, where we have H, E, L, L. So you get the idea, right? We'll keep going like that until this is for hello. We'll do the same thing for world, right? We want same thing for world. So we'll start with W. We'll do that till the end. So we want something like this. The reason for this is so that we'll be able to, when we do this, remember, we'll also have, and what's it called? We also have we also have 5 in here, right? I think so. We'll also have hash, then H, like we'll have all that in that array, right? So this would enable us to be able to loop through this array, manipulate it as we want, you know, as we move forward. So the first thing we need to do in order to achieve that is to, first off, we'll say, let what name will I call it? Let's say I'll use a simple. I always have issues with variables. So I'll use a simple, this variable. I'll say v equals to, so we want a vector of characters. This is what we want. So now that we want a vector of characters, we'll say s dot chars. So this is how we do it in Rust. I want to collect that value, and okay, let's see what we'll get. So when we log v, let's see what v gives us. Okay. Cannot be formatted. Yeah, of course. So I'll format it like this. Run this again. Of course. So this is, you can already see that this is what, according to what I had illustrated previously, this is what we have, right? So we have that. So now that we have that, the next thing that we have to do is, how do we, move through this array, pick the element that we want, do what we want, get, use this, 5 in our, logged array of, vector of characters to get the length that we need, right? Because 5 will give us the length of this. So it is going to tell us where to stop. Same as, this would give us the length of word, right? All right. So the first thing we have to do is, of course, we have to, loop through, this array, right? We have to move through it, and we have to move through it and, pick the particular words that we need. And because at this point, we want to move, like we are not moving at a predicted pace. So if you listen carefully, right, we're not moving at a predicted pace. We are going to be moving, we're not moving sequentially, right? So we will not use, will not 100% rely on, just a for loop here, right? We also use like a while loop and everything, right? It will make sense as I, go on in my explanation, right? But basically, we want a situation whereby we'll be able to, move through our array, pick the length, get a slice of it, right? Use that slice to determine, the current position that we are, and continue moving forward, right? So Now we say let's do something like let's it's I be equals to 0. Okay. So now the next thing we say is while I want to use a while loop, I is less than v dot length. While I is less than v dot length. Okay. So while I is less than v dot length, we want to do some want to do some interesting things in in the body of our array. Um, you know in the body of our in the body of our while loop, right? So first things first, we want to say um okay. Okay. So we have let I equals to 0, and we'll also go with let's okay. So once again, we want to be able to go through. Let me copy this here. So copy this here and comment it out so that I'll be able to easily go through our array and reason about it. So that's why most times I try as much as possible to put it directly where I can easily see it. So now we have our while. So we are doing while while I is less than our array. So now we want to say let j. So we want j is also going to be mutable. So let j be equals to I, right? Now I explain why we do that, right? I'll explain why we do that because the reason why we're doing this is because we want to start at the same position with j as we move through the array. So now the next thing we're going to do is that we want to be able to increment j. We want to be able to increment j when a particular character is not equals to this hash, right? So let me zoom in a little bit. I don't know if this is right. So what I mean by this is, remember I is 0, right? So we're starting at the index of 0, which is 5, right? And now in our while loop, right, we are saying let j equals to I, which means I and j are starting at the same position, right? But we need a way to move, j independently without affecting y, right? So the way we'll do this is we want to check, right, in our vector. So this particular guy, so in this stuff here, let me delete this. So I want to check here. So remember we're starting at position 0. So I and j for the first iteration, both of them are at 5. So they're not. So let me just write the code so it makes sense. I'll say while vj is not equals to hash, right? So we want to go ahead and say, j is plus or equals to 1. So we want to increment it, right? So that's basically what we want to, do here, right? So now what we are doing is we are saying we are starting both I and j at the same position, so the position of 0. So now we'll then go ahead and run this line of code. We say, while j, is not equals to, hash, move j alone. So we increment j. So j moves from being 0 here to becoming 1, right? So when we get to this part, right, when it is actually, the case, we'll then, skip this line of code and, go to the next line of code, which I'm going to, write shortly. So now, the next line of code I'm going to write, what we basically want to do at this point is we want to, be able to take our string, right, that comes in. So the string that is coming here, we want to get a slice of it. So getting that slice is going to give us the length, like it's going to give us the length of the word that we need to push into our array, right? So using that, we're going to get the word, and then we are going to, we're going to get the length, and using the length, we're going to now be able to, like, get the word and all. It's quite complex, right? But I'm trying my possible best to, like, explain it the best way I can. So the way I would do this in a safe way in a language like Rust is we use something called if let. Okay. So if let okay, so we are basically, it's kind of like the structure inside. So we say we pass the length in this place. We say is equals to s dot, right? So we want to get like the slice of, not dot, sorry, we want to get the slice. So to get this slice, to get that 5 in our string, remember, we are dealing with our string at this point. We're not dealing with the the array that has been split, like the one that we split into characters. So this is what we are dealing with at this point. So I'll close this and I'll paste the guy we are dealing with. No, let me just put him here. Put him here. Yeah, so we are dealing with this guy, right? So we want the slice. So we want to get, and how we do that in Rust is we'll pass I. So we know that I is at position of 0 at it's still at the position of 0. We've not, like, incremented it or anything. So we'll pass I. So we say, everything from I excluding J, right? So we want everything from I excluding J. Remember, J is at position 1, right? This is index 0, this is index 1. So we want to get 5. So we'll do something like I dot dot J, right? That's basically how we are going to get that. So now, remember, it is still a character, or a string slice or whatever, right? It's still a character, I mean. So we have to convert it from that character to a number. And how we do that in Rust is to use something we call pass. So we use the pass keyword, and then there's another thing we call tuber fish, where we are able to now collect it. We're able to, like, basically determine the type that we want that particular value to be of. So we say something like usize. This can either be an I32, which is still an integer type, but in this case we're going to use like a usize. So usize. I'll do it like this, right? So once we do this, we then have to, like, ultimately call it. So after that, we now have our length. If I go ahead and I print, so let me say I print. I go ahead and I do this and I pass length. Let me call it length. Let me comment out every other place we are logging something. So here, comment out this guy. What else? Where else? Okay. So if we do that, close this. I have to close some things. I have a lot of tabs open, and my this thing is beginning to warn me. My browser Chrome is beginning to warn me to close some things. So let me quickly close them. Okay, I think I've closed one. Should be fine. All right. So as I was saying, right? So if I log the length at this point, right? Let's see what happens. So when I run it, hopefully it doesn't break to pieces. All right. So you can see that we have, like, our two lengths, right? But this is still running, like, it's running like infinitely. So I will just terminate that process. All right. So we have those two lengths. So what do we then do with that length? So now we now have to look for the word itself. So we say something like let me call it word, right? And it's going to be a string. So we are going to use that same format to use here to get this to help us, get the string itself, right? From I think from our array, right? So that's basically what we are, basically what we are going to do at this point, right? So we're going to say that is equals to v. Remember, this is this guy v basically gave us this, right? So we want to, and in that place we want to now get the slice. So how do we get the slice? So if you look at this, right, we want to get everything after the asterisk, which is starting from H all the way down to to the last character here, which is O, which makes the hello itself, right? So that's what we want to do. So that's what we want to. So the first thing we want to do, we say J, right? plus 1. So j is at index of 1. So j here is 1 plus 1 is going to give us 2. So that's the first number. So these two guys are ultimately 2, right? Now, I will not put like the two dots and stuff, right? The next thing I'm going to do, I'm not going to say, now that same j, right, plus 1, which is still 2. So we're at this point. Then we want to add the length to it. So we want to say 2. So this is going to be like 2 plus 5, which is going to give us 7. So if we count 0, 1, 2, 3, 4, 5, 6, 7. So we are stopping at this 5. Remember how our slice works. It takes everything here, excluding the last position, right? So we'll now say plus the length, right? So plus the length. So yeah, this is quite complex, right? But this basically gives us, that the slice of, hello from this vector or this array, depending on the language you're coming from. So after that, we now want to use, eta. This is a way of getting, I think, reference. We're not taking ownership of it, so we're getting like reference of, that particular value out of, the vector itself. Then we want to then collect it. So we collect it because we are collecting it back. This collect is what is going to now convert everything we have here into a string. So we'll say collect, right? So now after we do that, of course, we now need an array that we are going to push that value into, right? We need an array to push it into. So what we are going to do is we're now going to go back and, initially we did not declare an array. So we'll just call it let's vec equals to, of course, it's going to be a mutable one because we are pushing things into it, right? So I'll just call it res result is equals to vec, just simple, right? So now we have our word, right? So the next thing we're going to do, we're just going to go ahead and say res dot push, and we'll pass the the word in there. Then after doing that, we then want to increment our the index position of I. So what is going to be the position of I? The position of I is basically this guy here, which is 7, right? We want to move I from here all the way to 7, and this is why we could not use a for loop, right? Because a for loop, we are moving at consecutive pace, right? We know that we are going to be moving at consecutive pace. But to actually use while loops when we know that we are going to be moving at unpredictable pace, right? If that even makes sense, right? That's basically why or the situation you should be looking out for when you want to use, like when you're confused between using like a while loop versus a for loop itself, right? Right, so I'm just basically checking Twitter. Okay. Yeah, I'm basically checking Twitter. All right. So now, but okay, so let me just go ahead and do the incrementation, right? So I'll say I at this point is now going to be equals to J. We know that J is at this position, so it's at 1. So is at index of 1. So we want to say J plus 1, which is going to be 2 plus 5, which is this guy that we're getting here. So that's 7. That want to move I all the way from index of 0 to the index of 7. So if we count it, this is 0, 1, 2, 3, 4, 6, and 7. So I moves and lands on 5. So we then end this here, and at the end of the day we just go down down here and return our res. So return our res here, res. All right, so let me just run this code, and once I run it, and then we'll go over it once again. So you can already see that I think I'm logging the length somewhere. I'm logging the length here, so we are picking the length 2 times. That's 5 and 5, and all that. So you can already see that we encoded this format. We're not decoding it, coding this format. Like I said, use any type of value in our any type of separate. Let's try an underscore and see what happens. Okay, it's compiling, finished, main thread. Okay, the length is 14, but the index is 14. I think that underscore is giving us an issue. Let me try something else. I'm just experimenting at this point. Let me try What does the question even say? Okay, the list design two functions and code can take a list of string and combines them into a single string. Okay, the code take a single string and all. I'm trying to see if we can try something else. Let's say like full stop. And see that we'll still get the same. I don't think it's. I don't think that that can be the case because I think in one of the examples we have something like semicolon. I think the only allowed separator that we can use here is the hash itself. So I guess that's why we are getting this error. Um, yeah. So I would put that back. I'll just run through it once again, for us to, finally land it, right? So the encoding is simple, right? We are encoding into a format that we want. So first of all, we get the length of that particular string in our array. Then we push a divider, which is our hash, and then we push the string itself, right? So that gives us an encoded format. So in order to decode it, the first thing we do is, of course, we create an empty vector. After creating an empty vector, we then, split, that particular string, because remember we've encoded it so it's a string. So we split it, or we, create a vector of characters where each and every one of them are, single characters on their own. The purpose for doing this is so that we'll be able to, you know, move through that particular array at different pace as much as we want. So the first thing we did is we created an index of I, which we, equated to 0. So it's going to start at, 5. Then we use the while loop. The reason we are using the while loop here is because we are moving at, we're not moving at consecutive pace, right? So we can jump from anywhere, like in different positions in our array or in our vector, right? So then went ahead and we equated I, which is 0 to j. So both of them are starting at the same position. But this guy is very important because at this point, we are you saying v.j, right? We are checking if v.j is not equals to, hash would increment. So when it's not equals to hash, we increment, right? So we do that, and when it is equal to hash, we stop incrementing and we run this part of the code. So the first thing we do is to get the length. So we get the length of that particular the particular word that we need, and we get it because we already encoded that length in our string as 5. So we'd say I.j. I is at position 0, j is at position 1. So we want everything from 0 excluding 1. So that gives us 5, right? So we have length here. That's why when I run this, you see 5 being logged or being printed twice. You can see it here. Right? So we have it here printed twice because we have 5 twice in our string, right? So now that we have the length, we then go ahead to get the slice of the word from our vector, right? So we say we want to start from, we want to get like h, right? So we'd say j, which is at position 1 plus 1, that would give us the index of 2. So this is 0, 1, and 2. So we're starting from h, right? So we want everything from h all the way to circle, right? Excluding 5. So we'll move all the way down. So we say j, which is 1 plus 1, which is 2. So this together gives us 2, plus the length. Our length, remember our length is 5. So 5 plus 2 gives us 7. So if we count all the way from here down to this 5, it's 7. So 1, 2, 3, 4, 5, 6, and 7, right? Sorry, 0, 1, 2, 3, 4, 5, 6, and 7. So the way a slice works, right? We want everything from the index of 2 all the way to the index of 6, excluding 7 itself, right? So that's basically what we did here. After doing that, we just automatically pushed it into our vector, and then we incremented I. So basically moving I to the position of 7, which is 5, and we continue that process again until we are done and we returned the vector. So yeah, that's basically how we solve this. Guys, once again, you can ask me questions. Please help me retweet the live stream. We started very late today. I'm trying as much as possible to finish this before 12 o'clock. I really appreciate you guys, who come on these live streams, show your support and everything. And I would appreciate if you guys, help me, retweet this, so that more people can, can get to, see it. Anyways, yeah, so that's that. So we'll move to the second question, right? So I'll just go ahead and comment this out. Go ahead and comment this guy out. So I'm moving to the second question. Okay, let me out. So this one is another very, tricky question that we have to be absolutely, we have to really think deep about how we are, going to approach it, how we are going to solve it, and everything, right? Because it requires us to, use a set of, different approaches to solving different problems to try and attack this particular, problem itself, right? Right. So let me comment out everything. Comment this out. All right. So I will just take down the valid parent drum and remove this guy. So this question, it says, let me split it into two. So it says, given an unsorted vector of integers, find the length of the longest consecutive element sequence. So and one thing about this one is that you know, we must solve it in an O of n time, right? And I forgot to mention the time complexity. This is something I always make a mistake of not doing, and I'm incredibly sorry for doing that. But I'll get back to the time and space complexity for everything at the end of the video. But basically, this question is saying that you know, we should solve this in in an O of n, right? And what that means is we're not going to solve this using any form of sorting, right? We're not going to do like in Rust, we have some method. I think we have the sort method, we have sort by, right? We have these both methods, and all these methods they have an O log n. Is it O n log n? Yeah, they have an O n log n time complexity, right? So they are not as fast as the O of n, right? So I think it's something like this. O n log n, right? So they are not as fast as the O of n. So the question is saying we should solve this without, using what's it called? Without using, the sort algorithm, because once we're able to sort it, we can, immediately, just quickly get the consecutive ones, right? As of course the consecutive ones without, any gap between them. So let's now look at some of the example. So the first example here, we have 100, we have 4, we have 200, we have 1, 3, and 2. So if you look at this, you see that we have, this is 4, this is 3. So we have, sorry, we have 1, we have 2, we have 3, and we have 4. So for that reason, we have a consecutive, a consecutive sequence of 4, right? Because we have 1, 2, 3, and 4. If we did not have 5 and we had 6, it will not count because we don't have 5, right? So they are not consecutive, right? So that's why we have 1, 2, 3, 4 here. In this case, right, very important use case, sorry, a very important example. And, here you can see that we have 0 and we have 0 repeated twice, right? But at the end of the day, if we count the consecutive elements, it's not be up to the amounts, and that's because we have to think about that particular trade-off, right? Which is something I'll get to. But basically, here we have 0 and we have 1, we have 2, 3, 4, 5, 6, 7, 8, right? So what that means is, so basically, what that means is here, hold on, let me see, 0, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, of course, and 10. Okay. So I would just go ahead and rewrite this stuff, right? In I'll rewrite it. So let's say we have 0, another 0, that's 2. So we have 1, 2, 3, 4. We have 5. We also have 6. We also have 7. We also have 7. We have 8. We have 9. Right? Sorry, we have 8. It ended in 8, right? So if we count everything here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But the expected answer is 9, right? So what does that tell us? That ultimately tells us that any place we have a duplicate, we have to, take care of that duplicate. So we have to like throw that duplicate away, right? And how do we handle this? In every programming language, we use sets, right? In JavaScript, we have sets. In Golang, we have sets. In Python, there are sets, right? We use sets to get only unique elements. And it's exactly the same thing we'll be doing, here in this, in this very case, right? So we'll be using sets to, handle the duplicate values so that we can only focus on the non-duplicate value. So if we take out one of the zeros and we count again, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you can now see that we have 9. But of course, we cannot sort because the question says we have to solve this in an O of n. We cannot use like, a sorting, cannot use a sorting method that comes with language or something, right? Because we want something that is better than an O n log n time complexity. So let's go ahead and take this out. Another thing to think of is whenever we have like an empty array, we just return 0. So this is one trade-off that we need to deal with. All right. So without talking too much, this one is quite simple, right? It's not it's not very difficult if you get like if you sort of understand the mechanics around it. I think some of the issues that one might struggle with such question is understanding how to, maybe if you've not really used sets before in your preferred language, and you don't know how to check if a set contains something. So like in Rust, we have like set dot contains, right? How to use it, stuffs like that. I think those are the only things that would really, put you off in this kind of question. Aside from that, this is a very simple question to solve. I think it's a LeetCode medium question, but I would argue that it should be like an easy question because if you've like, in my opinion, right, I would argue that it's a LeetCode easy question because I believe it's very easy. And because once you have your sets, if you just practically solve the problem, the rest is you thinking about the problem. How am I going to check whether my set has this stuff? You know, that's just basically then thinking about like how do I check if a value smaller than the current one I've met is currently available in my set, right? That's just basically how it is. So the first thing we are going to do in this case is that we are going to take our vector and put it into a set, right? So we are taking everything and we are just like, let's say array.push, right? Something like that. We are putting everything into our set. So at that point of doing that, our set is going to remove any duplicate that it comes around, that it sees, and just leave only unique values for us, right? So so how do we do that? So first of all, in a language like Rust, so what I would do, I would first of all remove this guy, and I'll comment out this guy. And how many hours have we been? Okay, this is about an hour. Interesting. Okay. Um, So first of all, we need, like I said, we need a set. In Rust, we do that by using importing sets. So say use is it std? Yeah, std collections. And of course, it's not like sexually transmitted disease, it's just like std, like standard library, right? So for those of you that would say, anyways, so we say hash set. So with this, we've gotten like our hash set into our solution. So what do we want to do? We want to every number that into the function into a before we even start touching doing anything with it, right? So the first thing we'll do here would say let's it set, and because as usual we are always like collecting and stuff. I'm always collecting values. If you've been following my live stream, you'll notice that I always use something like this, right? Like, s dot characters dot collect, and I will define, a vector. A vector is like an array, right? It's just like an array, like in JavaScript or so, and I'll call it characters. So what this does for me is an easy way for me to, get something like this, right? So it's easy, right? Rust is easy, right? But people feel like Rust is difficult and stuff, right? It's easy once you just understand, the principles of ownership and borrowing, and sometimes lifetimes, right? It's practically an easy language, for anyone to, as long as you're not doing something really, even if you're doing something really complex. Rust is, quite easy to use. Anyways, I also did something like that here, right? So where I, took, every individual, character in our vector, and iterated over it, and turned it into, collected it into a string, right? So it's the same thing I'll be doing here too, right? So at this point, I'm going to define that, okay, I want a hash set. I want a hash set. And in that hash set, I want, its numbers. So it's going to be an I32. This is an I32. I'll say it's equals to, so I'll say dot into eta. So into eta, the difference between into eta and eta is that eta itself, it's like a reference, right? It doesn't consume the eta itself doesn't consume our vector, but into eta consumes it and converts it into something completely different, and which is something what we are doing here. But then we'd say into eta, I want to collect. So if we collect that, and if I go ahead and print this, right? So if I print this, you'll see that it will change from a vector to a hash set, and a hash set is mostly in an object format, right? So we are coming from JavaScript, and object, right, is basically something like this. So something like this, right? It's basically like this. So we have them inside something like this. I'll delete it. Let's just go ahead and see. So I'll print line. So guys, once again, please, I think we're about 254 people on the live stream, and we have only about 7 people that have retweeted it. Please help me retweet, the stream. Possibly, drop a comment. Help me, right? Please, both on YouTube. I have like less people watching on YouTube. I don't know why. Like YouTube is, I don't know. YouTube is very it's somehow, right? I think okay. As of now, I have one person watching on YouTube. Drop a comment, ask questions. I want these live streams to be interactive, right? So I'm streaming on X, which is Twitter and YouTube at the same time. So please drop a comment, help me retweet, help me share. I really appreciate you guys. We're about 254 people on the live stream. We can get up to like 30 retweets. It means a lot to me, to be very honest. But anyways, let's continue. So we have this, and we'll then log our sets. So the reason I always print, not log, the reason I always do this when when I'm doing NeetCode, because I try as much as possible to like understand how the data is changing. Being able to understand how my data changes over time gives me an understanding of what I'm working with and the things that are available to me, right? So if I go ahead and I run this, so you'd see, okay, yeah. So of course there will be an issue. This is supposed to be collections, not collection, and this is print. There is no T here, so I would update this S, and there's no T here. And you can already see how explicit the Rust error messages are, right? So it's already telling me that could not find collection in the standard library. So I have to update that. I don't think this error message is as useful as it should be. It should actually point you and tell you that, okay, this is we have something like collections. You should update it to collect. I've seen error messages like that, like this particular one now is basically saying cannot find the macro print lane in this scope, right? Then it goes ahead to tell you that there is similarly a named macro called print line defined here. So, and it goes ahead to tell you I should add plus. So I think they can do the same thing or probably, who knows, I could just maybe contribute to the who knows, I can just contribute to the standard library and suggest this particular updates. If they will accept my PR, I don't know, but that's a different conversation altogether. But the point here is Um, the point here is, you can already see how helpful the compiler is for someone that is just coming to Rust as a newbie, or someone that's just learning it. You can, if you have the patience to read these error messages, you would see that it's really helpful. At least this one is helpful, right? So let's close this and run it again. Run it again. What am I getting? Okay. It's saying cannot find the macro prints. Oh God, I still wrote it wrongly. So it has to be print T before L. All right, so run this again. All right, so you can see what I said initially, that it's going to be like in an object. So we now have all our values. Of course, they are at random, right? We cannot really define or determine the position that they would be. So if I run it again, now we see 100 is starting and 200 is ending. If I run this again, it might be 200 starting, and okay, so now we have one starting, 200 and 104 ending. So it's like unique, right? It's random, it's randomized, right? So we cannot really determine it. But that's not our business, right? That's not what we are here for. So now the next thing we want to do is we want to go ahead and loop through that particular, like for S in set, do a couple of things. So we want to get each number and right. So first off, we only want to start counting from the beginning of a particular sequence. So what I mean by that is, if I run this again, it gives me this guy. I'll copy it. So let me put it here. So, or let me just use our normal array format, how it is in our array, so it can run through it. It makes more sense. Okay. So the first thing we want to do is we want to first of all, when we have a number lesser than the current number. So let's say, for instance, we 100, right? We want to check if we have -1, which is 19, in our set, right? So if we have that in our set, we will now, go ahead and we'll know that, okay, this particular number we are currently at is not the lowest number. So we'll start counting from there. So that's how we'll be able to determine, the beginning of our sequence. So how do we do that? I'll comment this out. So in order to do that, we'll say if set dot contains, right? One set dot contains, we want a reference to, what's it called? Want norms? Is it norms? Yeah. I'll be norms or set. Let me use, no, it's set. Sorry, S -1, because it's S that we have here, right? So we want to check if it is not, right? So if it is not, that's what we want to do, right? So now, okay. So now, right, we need to keep track of two things. We need to keep track of, the current value and the count of that value. The count that we're keeping track of is going to go ahead and update something. So let's say let's mute dot longest equals to 0. So that particular value is going to go ahead and update this guy if it is greater than 0. But we'll get to that point, right? I think we're still further down the line from there. But basically what we are doing here, like I said, is if we pick 100, right, we want to check our set, does it not contain that particular number, which is 99, right? So because basically what we are trying to do is we are trying to start from the beginning of our sequence, right? So in order to do this, we want to maintain two things. We want to maintain a current value, which is going to be equated to S, right? Because the reason we're equating it to S is because we do not want to directly modify S, which is what we are getting from our set itself, right? So we'll go ahead and say let's mute current. So let's call it core is equals to S. So we'll now use core anyhow we want without affecting S. So we'll then go ahead and maintain our count. So we say let's mute count be equals to 1. We want to start from 1, right? So now we now want to say while our set contains, remember, right? We've checked if this guy is not in our set, right? But in the case where it is in our set, we now want to like run everything here. So we increment it to, to one. And also we're always like starting from, the beginning. So what that means, again, let me explain is if we check, we do not see 99 in our set. We know that we are we are at the starting point in our set. So we're at a current, like a number in our set, right? So what we'll now go ahead and do is we'll then go ahead and increment, assign that particular number to be the current number, and we'll increment our count to one automatically. So now we'll now say while our set contains current, remember current is 100, current plus 1. So we're now checking for 101, right? So while our set contains 101, go ahead and increase the current, which is this guy, and the count, right? So that's just it. So we'll keep doing that. We'll keep being in that while loop. We'll keep running in that while loop until we meet another value again, right? But if we don't have that current plus 1, we will not run the while loop at all. We'll just go ahead and increase the value of our longest. So let me just write the code to make sense. So once again, the same thing I did before, say current, so reference to core plus 1, and inside here I just want to say core plus equals to 1, and count plus or equals to 1. So we're incrementing, we'll keep incrementing. But if that is not the case, right, we want to now go ahead and say if our count is greater than longest, this guy. So we just want to go ahead and increase. So we just say longest guy is equals to count. So that's basically it, right? So that's what we'll basically do at that point. So now to go over this again, because basically we've practically solved this problem at this point. What are we doing? First of all, we've converted it to a hash set. It does two things. It does one thing for us. It takes away duplicates, right? Then it gives us something that we can loop over, we can work with, right? So the first thing we are doing is we are checking, are we currently at the first integer in our set, or is there a lesser one, right? So for instance, let's say if we find 99 in our set, right, this does not run, right? It does not run. So what that will tell us is that, okay, this particular stuff is not going to run. We'll then move to the second, element, or sorry, the second integer, right? We'll also do the same thing. If we have 4 minus 1, we have 3, right? This will not run again. We'll continue doing that until we get to the smallest element. That element is now going to be the one that's, we are going to check that one, and we're now going to say, for instance, when we get to 1, which is S, here is now 1. So 1 minus 1 is 0. There is no 0 here. So yeah, that is true. We'll now run this part. So we'll go ahead and we'll assign 1 to current, and we'll increment count by 1. Then we'll check inside our while loop. Does our, so by the way, this is contains and not contain. So this is contains, correct that. So we'll check in our while loop, right? Does our set contain 1 plus 1? Yes, it does, because we have 2 here. You can see we have 2. So it goes ahead and it increments this count, right? It increments both of them. Then we go again. Now we know that our current is now 2, right? So it's now 2. So we'll go again and say, does our set contain 2 plus 1? Of course, we have 3, right? So it comes again and increments these guys, right? So now current is now 3. Outside here, current is now 3. So we check again. Our current, does it have, 3 plus 1, which is 4? Of course, we have 3 plus 1, which is 4. So we go ahead and we increment, our count to, 4. And we increment this one to 4, right? We add 1 again to the 3 we had here, so it becomes 4. So now we have 4 outside here. We now check, does our set contain 4 plus 1? No, it does not. We don't have 5 here, right? So we know we've come to the end of this guy, right? So he then goes ahead to run this line and says, remember our count right now is 4, right? So when I say, is our count greater than longest? Of course, longest is 0. Or as at the time when we got to 100, longest was 1, right? So we say count is greater than, that is 4 is greater than 1. Then we'll go ahead and we assign this to our longest, and we go ahead and we return it here, right? So we'll just return longest. So if I run this, so you can automatically see that this is, what we get at this point. So it's a very simple one to solve. Once you understand, like I said, it's more about understanding, the mechanics of, how to bend the language you're using to your own will, right? So if you know how to like use sets in, your preferred language and all, this particular problem is another problem. I think it should not be a medium problem. It should be an easy problem. I don't know. It's just my own opinion, right? But then you can already see how easy it is, right? So we just basically convert, like we push our array into, or our vector from Rust into a hash set, right? So that then gives us unique values that we can then loop over, check if the current number that we are currently on is, if we have a lesser number than that. If we do, we don't go ahead to run anything inside here. But if we don't, then we go ahead to run everything inside here. So at the point, we then, when we find a number that has something lesser than it, so we keep adding, incrementing the current and the count. We keep doing that all the way until we have a count that's, until we get like to the end of the set, and we just go ahead and return the longest value. Right. So I'll go ahead and run this for, let's say, for this example. And for this example. So let's see whether to give us 9. So of course, the value here is 9. So yeah, that's basically how, you solve this question. Like I said, in my opinion, I believe this is a simple, I believe this is an easy question, but for some reason, they made it, a medium question. All right. So we'll move on to the last one. And this one is actually an easy question. And we'll move on to the last one. So this is basically the valid palindrome problem, right? All right. So let me comment this out. Okay. So this question basically says, given a string, right, return true if it's a palindrome, considering only alphanumeric characters and ignoring, cases. Okay. So we have to ignore cases, right? So something like a man, a plan, a canal, Panama is going to be true. Because we are going to remove everything that is not alphanumeric. So the semicolon here goes off. P, of course, A would match, with. So basically, what is a palindrome? A palindrome is a word that reads the same from both sides, right? So we have a man, a plan, a canal, and a canal Panama. So if we split it from the back, we have A, we have man, right? So P A, you can see P A, PLAN, right? I don't know how it's sort of like confusing, but at the end of the day, right? A matches to A, M matches to M, A matches to A, N here matches to N, A again matches to A. You can see P matches to P. So basically, that's basically what a palindrome is, right? Same characters, beginning and end, all the way till we get to the middle, right? So that's basically what a palindrome is, and this is a very easy one to solve. And basically here we're using something called two pointers, right, to get the optimal way of solving this, right? Of course, I don't think it would be wise to solve it any other way rather than using two pointers. But then there is a caveat, how do we take out, non-alphanumeric characters like space, the comma, the semicolon and all that. How do we take them out? Right. So let's find out. Right. So now, first things first, right? This is idiomatic Rust, right? Of course, you'll be able to write it in your own preferred language, But basically, we have something we call to lowercase in Rust that converts a string like this to lowercase, right? Then after that, we will then, of course, as we usually do, we convert it to characters, so individual characters. And then because we've converted it to individual characters, we will then be able to go ahead and filter through it. Because once we've converted it to individual characters, it is now a vector, right? It's now an array. So we can now go ahead and filter through it. So it's at the point of the filtration that we will then check each element in that array to see if it is an alphanumeric element, right? So sorry, if it is not alphanumeric, right? If it is not a number or a character or an alphabet or so. So if it is not, we'll just automatically filter it off, right? At the end of the day, we'll collect it into like our vector of characters, then we'll go ahead and do our solutions and stuff like that, right? Now, um, okay. So the first thing to do is remember there is a trade-off here, right? What happens if you have like an empty string? What happens? We just want to go ahead and return through. No point of running through, but we'll get to that point where we you know do that particular where we handle that particular edge case. So, guys, once again, I think we are 9 minutes into 12 o'clock, and we have about 292 people on the live stream. I'm quite surprised, that we have this number of people on the live stream. I really did not expect it. Um, so someone asked, why are we hard coding 5 in line 42? Shouldn't it be? I'm sorry, I'm just seeing your. It's crazy. I'm just seeing this. Whoa, whoa, whoa. Where did I had code 5? Where did I had code 5, guys? Sorry. Yeah, 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 yeah. Thank you so much. Thank you so much. It should be length. It should be length. That was an oversight. Thank you so much. The design Lopa and Miles, not Miles. Thank you so much. That should be length, right? So I'll go ahead and run it. I'll run that code again to show that it works. I'm very, very sorry about that. I did not even see that message. So I do not have a moderator, right? I'm coding at the same time, and I'm basically the one still, controlling like my code space and everything. So let me comment these guys out and run that code again. So I'll run this. Let's see what it gives us. All right, so it still gives us that same value, right? Okay, so to prove that this works, because what you're supposed to pass here is the length, let's use a different example. So let's say let's use the second example. And I guess if I had like tested for the second example, I would have found out that issue, right? So let's just say we use 5 for instance again, right? And I change this guy to this and I run this, so it will break, of course. Hmm. Of course, it's not going to work because it would, it's of course it breaks, right? Because it would loop forever. Because we're passing we're hard coding 5. So I'll just change this to length. I'm so sorry I made that mistake. So if I run this, you see that immediately it works, right? So we've encoded it and we are now decoding it. I'm so sorry I made that mistake. Thank you so much. The design, I think the design looper and Miles, not Miles. Let me even reply to you guys. All right, thank you so much. I've corrected that. It's quite unfortunate. I don't know why it didn't show in my chat. Your message didn't show in my chat. It's crazy. I don't know why. It didn't show on my chat on my streaming software, but I've corrected it. Thank you so much for pointing that out. All right, so let's just continue. Whew. Okay, so where was I? So I'll comment this out. Comment this out once again. So we're in the valid palindrome territory. So here, and close this guy out. And okay. So now, like I said, right, we want to first of all, convert it to lowercase because the question says we have to ignore casing. So that what that means is, we have to convert it to lowercase. After converting to lowercase, we want to filter for, numeric things like for characters that are not, alphanumeric. That is either they are not alphabets or they are not numeric, characters. So how do we do this? Well, how we do this in Rust is we say let's use something like lectures equals to, so once again vec of characters. I want to say strs, which is what we are importing here, right? So strs dot, I want to change it to lowercase. So to lowercase. So now I'll just first of all go ahead and collect. So I'm doing this on purpose. So I would I'll print. Say print line. I should have print where I can just copy and paste it all the time. I'm tired of writing this stuff. Anyways, I'll pass chars here, right? So I'll run this. Let's see what we'll get. Of course, breaks because we'll not comment out these guys. So run it again. String is not an iterator. Oh yeah, it's not actually. So that means I have to I was trying to see if I would be able to illustrate basically the builder pattern, right? Where you basically append things one after the other. I thought that would have worked in this case, but then let me just go ahead and write the full code. So I'll say chars. At this point, let me try it again without adding the filter and it's alphanumeric. Let me see what it gives me. Crazy. It's supposed to work. Dots, of course. I want it to work. So this gives me, of course. So this is it, right? So we have this guy. Everything now is now let me use an example that is shorter, something like race car. I use something like race car instead of a man, a plan, a Panama, whatever. Use something like this is short. So I'll make car like a capital letter, and I'll make R a capital letter, and I'll add something like a colon. So when I run this, of course, you can see that right now we have this. Everything now is now like lowercase, right? So that's it. So we have that. So now, how do we take off the alphanumeric characters, the non-alphanumeric characters, which is this guy, right? And I think it's just that guy, right? How do we take it off? So we'll now come here. I'll say dot filter, and we'll pass in our closure. I talked about closure in one of my videos. Go and watch it if you want to understand how closures work in general, like in all languages. It's not just like specific to Rust alone. So when I say c dot is underscore alpha numeric, so we'll do this, and when we run this again, so I want to have so when we run this again, we should have it. Of course, you can now see that we now have we've taken care of that situation where we do not want we want to be able to compare them whether they are capital letter or not, and we want to only compare alphanumeric characters. So we've taken out anything that is not alphanumeric, and we've made everything to be like small letter, right? So we can compare them, right? So that's like the first stage. This is like the first and the most important stage. The rest is just basic let this equals to this. But let me not go into that. But let's just say let's mute I be equals to 0. Remember, I said we use while loop anytime that we want to move dynamically, like we want control of how we move our pointers, right? That's when we use like the while loop, right? So we say let I be equals to 0, and we say let's mute j be equals to, of course, chars.length, right? On this. So we want chars.length, that's what we want. So because the reason for that is because we are starting from the ending of our vector of characters. So we'll start from the ending and we'll move, we'll start the point, like the j pointer is going to start from the ending, the I pointer is starting from the beginning. So we'll compare two of them. If they don't match, if they match, we move, inward and we move backward. So we continue moving that way, until we get to the middle, right? So to make sense when I get to that point. So we've written that two parts. So say length. I'm basically rushing at this point because this is about an hour 39 minutes. Is a lot. So now we want to take care of this use case where we have like an empty string, right? So at this point, we now want to say, let's say, I think we can do is empty. There's something called is empty in Rust. So we can say if we can do if chars dot is empty, we'll return true. Or we can just do something like j because the length of j. We can just say if the length of j is equals to 0, right? So we just want to go ahead and return true. Right, so we've taken care of that use case, right? So the next thing we are going to do now, we're now going to go ahead and say, of course, if we don't add -1 here, this is going to give us an out of band error, right? So I'll come back to that. I want us to have that error, so I will come back to it and we'll fix it, right? So ideally, we want to do chars.length -1, right? But for now, we are going to just leave it like that for the purpose of learning. So now we'll go ahead and say while I is less than j, right? What do we want to do? We want to compare those characters. So I want to say if chars I is equals to chars j, what do we want to do? We want to remember I said I is moving from this direction, while j is moving from the back, right? So I want to say I plus or equals to 1, so that we increment the position of the pointer, and j is going to be minus equals to 1. So we are decrementing it all the way back, right? So that's it. So else, we just want to return false. Return false. This is a very simple one. It's actually easy on on NeetCode. At the end of everything, if none of that is the case, right? That is, if none of that is the case, we kept on moving and everything until I is no longer greater than j. We just want to go ahead and know that, okay, fine, all the characters match, and we'll just return true. This is a very easy one. Right, but remember, I said we're going to have like a bug, an out of bound bug, because we did not add -1 here. So let's run this and see what happens if correct. Of course, right? So if you look at this, you can see that we have an index out of bounds, right? The length is 8, but the index is 8, right? So we have to do like something like -1. So run this again. Of course, you can see that this gives us false, right? Because race car is not, is not a palindrome. So we can use something like a man, a plan, and Panama, whatever. So we'll use this, paste this here. Let's run it and see what happens. Of course, it gives us true, right? So we also test it for like an empty string. Okay, let's test it for an empty string. So an empty string. Run this automatically, it gives us what's happening? Compiling, exited with 0. Let me see. Still the same thing. So it's saying attempt to subtract from the overflow. Oh, I see. Okay, see, this is why I prefer to just check with the chars. So let's just do chars dot is empty. It's empty. Just prefer to do this rather than trying to be clever. Let's try that and see what happens. Still the same issue. Attempt to subtract from overflow. Okay. Oh, I see. I see the issue. I think I've seen the issue. So while this is crazy, right? So the thing happening here is that why -1 works for, and this is quite crazy. This is crazy, to be honest. Like two ways we can solve this problem. Two ways, right? There are two ways we can solve this problem. One is either we change the position of this guy, because of course we are using chars, right? We're no longer doing, j is equals to 0 and all that nonsense. Either we change him, and this is just a guess. I have another option, another solution in my mind. Either we change him and we put him here. Let's say we put him here and run it, and let's see what will happen for an empty string. Okay, fine, right? Either we do that, this works, right? In fact, this is how I would want to solve it. Or we can do something really clever and I don't know if I'll say it's quite stupid, but we can just comment this guy out and say, instead of doing -1, right, we'll leave it normal, but we'll come here and we'll do something like, let's say, we'll write that function, say if j is equals to 0, just return true. But now, right, before we go ahead with our while loop, we'll now go ahead and say j minus equals to 1, right? So we are doing that after we've checked. We'll now do that we're appending -1 to the length, right? So it's not so these two would also work. Of course, it would also work, right? But this is somehow I don't like this solution. But anyone that works for you, right? You can pick anyone that works for you. But I'll generally go with this guy. It's cleaner and more idiomatic and easy to understand, right? This is sort of like a clever code, and I don't see why you should like have two different steps of say, okay, let's do like j equals to 0 and we return through, then we then come down here and no, it's not. So this is my preferred solution, right? So this is my preferred solution. Call it preferred solution. All right. So guys, that's it. We've come to the end of this live stream. I think the live stream is now about 1 hour 45 minutes. I think it's the shortest I've ever done. Given the time and the circumstances and everything. Once again, I thank you guys for. Okay, so someone is asking what's the job market for us in 2026. Well, I do not have that information on my head. This is something that you can actually Google, or is you can Google it, right? But there is a market for it, but you cannot compare that market for us to markets for like JavaScript or Python, right? Even the market for Go, there is more market for like Go compared to Rust, right? And there are so many. I can go into like why that is the case, but it is just what it is, right? And one thing that is important to note is that these live streams are not just doing this thing in Rust. It does not mean that you cannot take these same concepts and apply them to JavaScript or any other language of your choice. If you love Golang, right, you can use these concepts in Golang, right? For instance, how do you convert a string to a lowercase in Golang? How do you now take that string and put it into an array and split it into single individual characters? Go ahead to then, filter for the ones that are not alphanumeric and, return an array, right? You can do that in Golang. You can do that in JavaScript. How do you check if an array is empty or a vector is empty? You can do that in Golang. You can do that in JavaScript, right? While loop, they are all available in those languages. How do you increment? How do you assign values? They're all available in all those languages, right? But one thing I can tell you sincerely is that, is there a job market for us? Yes, of course, there's a job market for us, right? I've seen a lot of jobs out there, but you cannot compare, the number of jobs in Rust to like a language like JavaScript that is practically, everywhere, right? Of course, JavaScript has more jobs compared to Rust, right? Golang has more jobs compared to Rust, right? So if you want to pick the language, of course, you can. There are jobs out there, and you can pick it up. The purpose of doing this live stream is to do it in Rust, and also try as much as possible to cover like a broad concept that speaks to every other language. And that's why I try to keep it as simple as possible. Anyway, guys, I hope I've answered your question, Victor. Once again, guys, thank you so much for coming on this live stream. This is about an hour, 48 minutes, not considering I think about 20 minutes that I had to like wait for people to come on the live stream. As of now, we have like 313 people on this live stream. I just want to say I appreciate each and every one of you for, supporting me this much. I had a lot of people retweet this stuff, about 42 people liked it and all. I really do appreciate each and every one of you. Yeah, so I think we've come to the end of this stream. Feel free to ask me questions, on X. You can send me a DM. Please go ahead, send me a DM. I'm willing to, as long as, they're reasonable conversations, like, talking about things like this. I'll always be there to like respond, give my answer and everything. Anyway, guys, thank you so much for, coming on this live stream, and I'll see you guys in another one. Bye.